Hello, today we're going to start section 1.3, Order of Operations and Simplifying Expressions. The objectives of this function are to become familiar with and able to apply order of operations, PEMDAS, to evaluate an expression, recognize and apply both the commutative and associative properties of addition and multiplication, and recognize and apply the distributive property to simplify an expression. Part 1, Order of Operations. First, do what's in parentheses first. If there are nested set of parentheses, do the innermost first. Then exponents. Then the third step is multiplication and division. Left to right. And then the fourth step is addition and subtraction, left to right. So multiplication doesn't come before division, nor does division come before multiplication. You just do those in the order they appear in the problem. Definition 1. When an expression contains no variables, such as after substitution, the process of performing all operations in the order prescribed above until we are left with a single value is called simplifying. Example. Evaluate each expression by performing every indicated operation in the correct order. So A, 2 plus 3 squared. So there are no parentheses, so we move on to step 2, which is exponents. 3 squared is 9, and 2 plus 9 is 11. B, there are parentheses, so we have to do what's in the parentheses first. So 2 plus 3 is 5, and then we have it squared, and then 5 squared is 25. C, here we have two sets of parentheses, but we do the innermost parentheses first. So we're going to do the 1 minus 3 first. Well, 1 minus 3 is negative 2. So we get 2 plus negative 2 squared, parentheses, times 5. Well, now there is still a set of parentheses, so we have to do what's inside the parentheses first. But once you're inside the parentheses, you still have to do the order of operations. So the exponents comes next. So negative 2 squared, which is 4. Then we can simplify the parentheses down all the way. 2 plus 4 is 6. And then 6 times 5 is 30. Now, D is just a common convention used by most computers and calculators. But when you write negative 3 squared in this way, this is the same thing as writing negative 1 times 3 squared plus 4. So because when we rewrite it this way, treating that negative sign as its own entity, as negative 1, when you do the squared, the exponent, you only square the 3, so then we get negative 1 times 9 plus 4, negative 9 plus 4, which is negative 5. If you wanted to square the entire negative so that it became positive 9 instead of negative 9, you would need to put parentheses around the negative 3, like so. Part 2, more properties of real numbers. When working with real numbers, we are concerned with two main operations: addition and multiplication. We've seen that we can rephrase subtraction in terms of addition and division in terms of multiplication. And this is the reason why we do addition and subtraction left to right and multiplication and division left to right, because we can rephrase the inverse operation in terms of the original operation. We've also seen the identity and inverse properties of these operations. Today we're going to look at a few more properties: the associative properties, the commutative properties, and the distributive properties. So, commutative property. For the operations of addition and multiplication, the commutative property says that when you carry out several of the same operations in a row, the order of the elements doesn't matter. For addition, the commutative property means that S plus R is the same thing as R plus S for any real numbers S and R. This extends to the sum of any number of terms. For example, S plus R plus T, no, that's the same thing as S plus T plus R, or it's the same thing as R plus S plus T, or one of any other ways you can rearrange those three letters for any real numbers S, R, and T. For multiplication, the commutative property is something very similar. It means that S times R equals R times S for any real numbers S and R. This extends to the product of any numbers of terms. For example, S times R times T is T times S times R, which is R times T times S. And again, whichever other way you can think of rewriting those three variables. The associative property. For the operations of addition and multiplication, the associative property says that when you carry out several of the same operations in a row, it doesn't matter which operation you start with. For addition, the associative property means that for any real numbers S, R, and T, S plus R plus T is the same thing as S plus R plus T. And this extends to any number of terms summed together. For example, S plus R plus T plus U is the same thing as S plus R plus T plus U, where the parentheses are around the R plus T now. And again, that will be the same for anywhere where you put the parentheses to start out. For multiplication, the associative property means that S times R times T, with parentheses around S times R, is the same thing as S times R times T, with parentheses around the R times T, for any real numbers S, R, and T. This extends to any number of terms summed together, very similar to the addition. So like if we did S times R in parentheses times T times U, that would be the same thing as S times R times T times U in parentheses. And any other way you can think of doing that. So we have some warm-ups using these two properties. The associative and commutative properties sound very similar when explained in words. The associative property arranges the order of evaluation, whereas the commutative property rearranges the order of the terms or factors. This makes them very powerful when used together. Example 3, complete each equation below to illustrate the associative or commutative property. So 3 plus 4 in parentheses plus 5 is the same thing as 3 plus 4 plus 5 in parentheses. 5 times 7 times 9 in parentheses is the same thing as 5 times 7 in parentheses times 9. 5 times 6 is the same thing as 6 times 5. 3 plus 4 plus 5 is the same thing as 5 plus 3 plus 4. Or you could have even did 5 plus 4 plus 3. That would have been another acceptable answer for this one. And that is it for part 1 of section 1.3.